Okay, so in the last week, we have introduced the basic information about SQL already. We also introduced different operators as well as these basic SQL queries, these semantic meanings. And in this week, we'll move to the remaining sections about SQL. We will introduce some basic information about bag and set semantics for SQL queries. And we will also introduce some other information like for writing more complicated queries in SQL, like with the havings, conditions, etc. like that. So I think this slides as well lecture can provide you with some basic knowledge about SQL, and it will also help you refresh your mind on this section as well. I think generally after we finish this section, you will be able to write basic SQL queries for both your project as well as the remaining sections. It can provide you with some necessary background knowledge. And if you want to further learn more about SQL, you can also try this SQL Zoom, this tutorial pages. The web page we send you in the last week to practice this SQL by yourself after class instead. Okay. Let's move to the bag and set semantics of this standard from where queries in SQL, which will be discussed in details in today's lectures. So we have two different semantics in the standard from where queries. This is SFW denoting the standard from where, the statements we read before. So these two semantics denoting this bag versus the set semantics of the standard from where queries. The main difference between them lies in these duplication records. Before, the standard from where this statement uses bag semantics. If you still remember in the relational algebra, we have talked about some operations, right? The selection, projection, product, and joins. Remember, for these operations, we never eliminate these duplications. We allow duplicate records in the results. Therefore, when we say this operations uses the bag semantics because it allows these duplications of the tuples. As a comparison of this bag semantics, we also have this set semantics. If you still remember, for sets, we don't allow these duplications, right? So the default for the union, intersection, and difference uses the set semantics. And it is expressed by the following forms involving subqueries. By using this union, intersection, and except, and difference, we can just connect multiple subqueries together to do either join, either or the cap, or the difference. Now we can write down a subquery in a parentheses, union a subquery in a parentheses. Then we can union the tuples in these two subquery return results together. So remember, for the unions, we use set semantics. In other words, for data tuples appearing multiple times in these two subqueries, they will be eliminated, and we can only keep one single record. Similar for the intersection and the difference. So for the bag semantics, we allow duplications. For set semantics, we don't allow duplications. We eliminate some of these duplicated records automatically. So these two semantics can be very important because they can provide you with different results when you're doing your project or doing your questions. If you don't know their differences, you can get very surprising results, which is not expected by you, right? We can provide you with some examples. In this page, we show you with an example. We want to find the happy drinkers. So from the relation the likes, drinker, and beer, the sales table, bar, beer price, and the frequency table, the drinker and the bar, it denotes that the drinker goes to this bar very often. So please find the drinkers and the beers such that the drinker likes the beer, and the drinker frequents at least one bar that sells the beer. Before we show the answer, you can also write down a query by yourself on your paper, right? How can we find these kinds of happy drinkers based on the likes, sales, and the frequency of these tables? I think we can do this query very easily, right? By joining multiple tables together based on the knowledge we learned before. And besides this, can we do this query in a different way? We can use this union or this intersection operators to help us, right? So what are the happy drinkers? The happy drinkers should be the drinks who like the beers, and the drink frequency at least 1 bar that sells the beer. Here we have this and as this connection words between the two conditions, right? So therefore, the first condition is the drinker likes the beer. It can be found from the likes table, right? Because in the likes table we have drinker, beer. So we can find the drinker and the beer information with this select star from likes. It will return both drinker and beer, right? We use this one as a subquery. And we have another condition. The drink frequency at least 1 bar that sells the beer. How can we find this drinker and beer information? We can use another subquery, right? We can do so by writing select drinker and beer from sales table and frequency table, where frequency.bar equal to sales.bar. So this subquery will return the drinker and beer information with the drinker frequency at least 1 bar that sells the beer. Between these two conditions, we have this and, right? Therefore, we can use this intersection or the intercept the operator to help us connecting these two subqueries. It will return the happy drinkers who both like the beer and other frequent at least 1 bar sells the beer. Remember, for this intercept, given these two subqueries, we may have some duplicated records, right? Data tuples. However, by using the intersect operator, we will eliminate these duplications automatically. In other words, for the return result, for the same data tuple, it can appear at most 1 time. We don't have any duplications in the return result for the complete query.